everyone, my name is Karishma. Thank you so much for attending this What's New in Maple 2021 session. I can't believe it's already been a year since we did the last session and I introduced Maple 2020. This time we're going to do things a little bit differently, and instead of PowerPoint, we're actually going to go straight into the product. And I'm going to show you some of the new features in Maple 2021, and I'm going to demo a few things that I think could be of interest. So let's kind of take a look at Maple 2021. Let me share my screen. And I'm just going to stop my video so I can more easily demo features. So here is a slightly reorganized version of our What's New in Maple 2021 page, and you can find this page in the help system. Now, when I stepped back and kind of looked at everything that we had done, I was pretty happy. I really liked this release. I felt like it had features for everyone. There was a lot of features that had been implemented based on customer feedback. In fact, I'll be completely honest, I struggled in terms of what to show because the audience who attends this What's New session generally tends to be very diverse. So I took a slightly different approach. I'm going to show you what I think you would be interested in, and I'm also going to show you some of my favorite features. Of course, if you want to see all of this, you can go to the What's New in Maple 2021 in the help page. You can also go onto our website and you can get more information. And as Rochelle had mentioned, I'm happy to answer any questions after the webinar. And if I don't know the question, I'm not shy to let you know and get the answer for you offline. So today I'm going to start with the math. And I generally always start this way because one of the things that we are committed to at MapleSoft with Maple is making sure that year after year we improve our math engine. So let's click and let me show you a few things that we've done in this area. So let's start with integration. Now the in command now supports the method option for indefinite integrals. Now the method option has been available for definite integrals for a long time, but in Maple 2021, we added this functionality when evaluating indefinite integrals. Let's go ahead. You can see this. So here I'm going to use the Meyer-G. And so you see the methods are Risch, Meyer-G, elliptic, Norman, and Traeger. And here we're going to evaluate the same integral using the Risch method. We've also added a new meta method called return verbose. And I really like this because it will return the result using most of the available integration methods in Maple. And this meta method has been added for both definite and indefinite integrals. So I'm going to do that over here. Give it's evaluating. And something you'll notice over here is that it kind of gives you, you can get very different forms of the answer depending on the integrator that you choose. So look in this one, depending on the integrator, you get different forms of the answer. And the same is true over here. And it tells you which ones don't work, don't provide a solution. So let's look at multivariate limits. Now, over the past few releases, we've been making steady improvements to Maple in the area of solving bivariate and multivariate limits. Now, if you'll recall, in Maple 2019, the limit command was enhanced for the case of limits of quotients of multivariate functions. And many such limits that could not be determined previously became computable. And in the bivariate case, Maple returned ranges instead of undefined. So here you can kind of see this is what was new in Maple 2019, this area. In Maple 2020, we added a math app for calculating bivariate limits and plotting critical curves in 2D and 3D. And so here are some examples, and I'm going to show you that math app in case you hadn't seen it. So it's over here. And I won't pretend to understand all the details of this, but I have played with this math app and I really love the visualizations here. So you can take a look, it'll generate the 2D curve and that's 3D. And you can go ahead and change it, find the constraint, Find the critical curves. Here's the result. There's an explanation, curve. So that's what was new in Maple 2020. So what is new in Maple 2021? Well, in Maple 2021, we can now evaluate limits where numerator and denominator are not homogeneous, but weighted homogeneous. So I have an example over here. Let's define this function g. So we'll go through this, kind of just set up, and now let's go ahead and find or evaluate the limit. So this is something that we couldn't do in previous releases of Maple, but that we can now do in Maple 2021. And you can see here the evolution of just how we're constantly making progress in this area. Another one, before Maple 2021, the following calls to the simplify command return their arguments either unchanged or with minor changes that left a call to the Lambert W function in the answer, as you can see here. This is the result in previous versions of Maple. Well, in Maple 2021, we can now, the following calls simplify the command. So here's the result. So another improvement in the area of advanced math is asymptotic expansions. So this command now can compute asymptotic expansions of the logarithmic integral. Here we go. And the last thing that I want to touch here is the multivariate power series package. So this is a new package, and it provides functionality for doing lazy computations with multivariate power series at high speed and high precision. It has a lot of package. I know the development team is very excited about it. And you can learn kind of more details and get more information about everything that this package can do in the what's new. And just a caveat, this is something that I learned, is in this case, the word lazy means that the terms are computed only when necessary, and that further terms can always be computed at relatively little cost. So let's go ahead and load this package, and I'll show it to you. Again, I'm showing this. Our development team is very excited. So take a look at this if this is an area of interest to you. And the last one that I wanted to show is you can now numerically solve differential equations that are collected together in vectors. We actually did this in response to customer feedback. So here we go. And now I'm going to enter this into the dsolve command. I can generate a plot. So this was at a request for a customer, and I'm happy that we were able to address it in this release. So those are the few things that I wanted to touch upon in advanced math. There's of course improvements to the GF package, LRE tools, and more improvements to generic linear algebra. Again, if you're interested, there's tons of information in the what's new. The next area that I wanted to focus on is language and programming. So in Maple 2021, Maple's next and break statements provide options to influence loop iteration, ending a single iteration of a loop or a whole loop early. And you can now specify which nested loop it is that you want to break out of early when the condition is met. And this is called multi-level break or next statements. And I'm going to show you examples of this. So here we have our for loop. Let me run this, and I'll kind of walk you through here. So you'll notice over here, we've added in this break J statement. So when that statement is executed, Maple immediately ends the loop with J as the loop variable. Now, instead of specifying the loop variable, we could have also specified a positive integer, n. And so in this example, we could have done the exact same thing by saying break 2. And using an integer parameter instead of a loop variable allows you to terminate a loop when there is no loop variable. So something to note for those of you who are kind of knowledgeable about our language and programming language is this is brand new in Maple 2021. So in previous versions, just you had the break statement without any arguments. So essentially break 1. And now in Maple 2021, we've given users this ability to have multi-level break or next statement. So the next example illustrates this with the next statement. And in this case, what we've done is we've just modified the previous example. So let me execute that. The next statement accepts a name of or integer, again, to indicate which loop iteration to terminate, so similar as before. And so this differs from the previous example in that it continues to the next iteration of the loop over j, rather than terminating entirely. So just something to keep in mind. So these are two that I thought users would be really interested in. Here, another new feature of both statements is that you can append a condition to a break or a next statement separated by the keyword if. And you can see that over here. So break j if ijk equals 222. And this means that the statement is executed only if the condition is true. So you can see that in this example. Now, there are other enhancements to Maple's kind of programming capabilities and improvements to the Maple programming language. But I want to talk about the new deal command that was added to the list tool package. And it's similar to the slice command. But I really love this example that we've created over here. So what we've done is we're going to use the deal command to shuffle 8 cards. So we have ace, king, queen, jack, 10, 9, 8, 7. Those are our cards. And here's our suits. So clubs, spades, hearts, and diamonds. And here I really like that we were able to use the typesetting command to append the suit to the card face value. So here it is. And now I'm going to use the shuffle command in the statistics package. And now I'm going to actually use the deal command here to deal 8 cards to 4 players. And you can see the results over here. So just a few things that I just kind of found this really interesting, so I wanted to share it. Again, there's a lot more that we've done when it comes to language and programming improvements, so take a look at the What's New for more details. At this point, I want to talk a little bit about performance. So for Maple 2021, the map command and other built-in commands related to it, such as element-wise operators and zip, have been significantly sped up. And so I have some tables over here that actually show you the differences in speed up between CPU time and real time. And so you can see that over here, and you can see the speed up for the map command over here. And the differences in speed up between CPU time and real time were present, are all almost entirely caused by a reduction in garbage collection. So just something to note, and the reason why I wanted to mention it is that especially the map command is used all throughout the Maple library. And so you'll notice that many of the commands in Maple that rely on these element-wise operators and the map command and these other built-in commands have, as a result, are more efficient or quicker, I should say. So something just to keep in mind with the map and its related commands. So the version of the GMP library used for larger integer arithmetic by Maple has been upgraded. And that adds improved support for new hardware, leading to small performance improvements for various integer operations. And we have micro benchmarks for basic integer operations, which show speed ups in the range of 5 to 10%. So that's another one. And there's improvements for, again, binomial coefficients and polyhedral sets. And I will leave that for you to explore a little bit more. So let's talk about LaTeX. So the LaTeX command has been rewritten for Maple 2021, and it can now translate everything that can be displayed on the Maple worksheet can be translated to LaTeX. And all you have to do is click on File, Export as LaTeX, File, Export as, click on LaTeX, and you're able to use that text file to take the code and translate it into a LaTeX file. So the whole facility has been rewritten in Maple 2021, and we did this because LaTeX is so important to our users. So one of the things that the new kind of functionality or the improvements to LaTeX gives is you now have equation labels, hyperlinks are supported, and you can see the input output in math. So what I wanted to show you here is I basically kind of created a worksheet. So you have some 2D math. So here's the 2D math, here's the output. Here I have the plot. Here I have some images, and I have a hyperlink. So those are things that didn't work very well in previous versions, and we have, like I said, rewritten the LaTeX engine in order to be able to support this. So what I did is I went to File, Export As, and I exported to LaTeX. And then I went to just an online tool. Let me show it to you. Pull this up. I uploaded the style file as well as the text, and compile this, and I can show it to you. Here is the generated LaTeX file. Here's my plot. Here's the image, and then the hyperlink. So that is something that I've shown to users since Maple 2021 has been released, and they are often very excited with this, which is why I wanted to bring it up in the webinar. There are, of course, more information, more details on what we've done in the help page. As well, if you go into Maple Primes, which is our community, the developer who implemented this, he's actually written quite a few blog posts and different articles about the LaTeX export functionality. And so if you have specific questions, I would encourage you to post them on Maple Primes. So let's move on to visualization. So the first one that I wanted to talk about is in Maple 2021, the plot and plot 3D commands are now smarter than before about choosing the domain for the plot if you don't specify one. So in previous versions, the domain would usually be -10 to 10, or for trig functions, they would be minus 2 pi to 2 pi. So what we did in 2021 is we analyzed the expressions and then now automatically select a domain that gives a more complete view of important graph features. So let's take a look at these examples. So these are lower degree polynomials, and you'll notice that the domain is always centered on the axis of symmetry. And it includes the zeros as well and extremas. So here you go, notice that the domain here is just, it's centered on the axis of symmetry. And you can use the explore command. You can easily see how the domain moves with the parameters. So here's the explore command. I have my little interactive application, and now I'm going to move this. And now you can see how it's updating, changing, how the plot domain changes. And so here are some other examples. So for expressions where the value is non-real for some non-trivial region of real arguments, Maple now tries to find a domain that shows part of the boundary. So in this particular example, if you ran it in previous versions of Maple, you would get an empty plot. But now in Maple 2021, we are able to generate or give you a plot of this function. And here you have a plot of a rational function will generally show all the singularities, roots, extrema, inflection points. And if multiple rational functions are given, you can also see the intersections between the curves. So here we have this function. And it has extremum around x equals minus 23 and a root around x is equal to 37. So we can obviously see the zeros, the singularities, and now I'm going to create a plot of this. And I'm going to use the plot to say display command and add points. You can see all of this information. So arrows. Many visualization commands use arrows, which in previous versions were always drawn with an arrowhead triangle at 45 degrees from the main shaft. In scenes where the x-axis has a vastly different scale than the y-axis, the angle wasn't always ideal. And in Maple 2021, we've taken this into account, an unconstrained view of the axis, rendering better looking arrowheads. So let me. And additionally, where many arrows show up on the same canvas, Maple 2021 automatically renders head proportions with the full scene view in mind, making plots with multiple arrows look much better. So we're going to switch gears a little bit. Let me talk to you about some of the improvements we made in Maple from kind of a teaching perspective. So the first one, and one that I'm pretty excited about, is we've added a new package for kind of solving and understanding ordinary differential equations. So one of the things I love about this student package is it shows step-by-step solutions for solving an ODE or a system of ODEs in the following categories. So we list them here. Now the student ODE includes two sub-packages. One is the solve, consists of solving ODEs and system of ODEs using the methods listed over here. And the other one is reduce order, which gives you commands for reducing the order of the ODE using 3 possible methods. And there's a bunch of different commands for kind of solving ODEs and systems interactively. So let me show you the solution steps. I'm going to load the package. It's with student ODE. Here's the first order ODE. And here's the steps for that. I now have a second order or ordinary differential equation as defined over here. And I can get the steps. Holding a little bit too. So I can have a second order initial value problem. And I can get the solution. And again, you get the point. So I can also do it for series solution as well. Since I have it, I'll just show it to you. So I'd encourage you, especially if you're teaching a class in differential equations, take a look at this package. We've gotten feedback. People, educators, students tend to really like what we've done. If you have any suggestions or for improvements or something that you'd like to see, please let us know. I want to show you one of these interactive applications that we have here in the student ODE package. I've already loaded it, but it allows me to select a system of differential equations. I can change that, update the system, I can specify ranges if I wanted to, and I get the plot. So here's another one. And you can even define your own custom system if you wanted to. So please take a look at the student ODE package. Some other improvements. The student's basic package now includes commands for stepping through arithmetic and algebra problems. So for finding solutions for long division, factoring steps, the solve step shows steps in solving an equation. ODE steps, as you saw above, shows the steps in solving an ordinary differential equation. And I'm actually have a separate worksheet where I'm going to show this. Working with degrees. So by default, Maple does trig computations in radians, but we've added a new degrees package and commands for doing trig functions in degrees. So these, you just have to load the with degrees package, and trig functions accept input in degrees instead of radians. And so these are the commands, cos d, sin d, so on and so forth. Here you can see. So that's 360 minus 360, so it's all in degrees. And this again came at the request of some teachers who said that, you know, their students wanted to work in degrees and had asked us if there could be a way to make that easier. Study guides. So the clickable calculus study guide for pre-calculus, calculus, and multivariate calculus are now available directly in Maple. And we did this again. These were something that, you know, a lot of educators liked the content. We wanted to make sure that it was accessible to both educators and students. It's all, you can explore the guides. They're in the help system. I'll show it to you. It comes up. It gives you an introduction, the chapters, and you can go through each one. So it has an introduction. There's some problems over here. We also have the solutions, each problem. And it shows you how the problem can be solved in different ways. So take a look. One of the things that I've noticed in showing this content is people generally love, because now you can kind of pick and choose what you want to show and how you want to show it. All of these documents can be modified if you want. So, you know, they're here. Take advantage of them. You don't have to start from scratch. So that's the pre-calculus study guide. And as I mentioned, each problem is solved 4 ways: a mathematical solution. So that's kind of how you see it in a textbook, using an interactive Maplet, using clickable techniques, and using Maple commands. So if you do have a preference, or you want your students to kind of do things in a certain way, you know, feel free to be prescriptive with them. Here's the calculus study guide. I'll show you the screenshot, and it's an example. And then we have the multivariate calculus study guide as well. So please take a look. I think if you teach pre-calc, calculus, or multivariate calculus, you'll find these very interesting. And they're all available in the help system. You can just search for study guides and you should be able to find them. So we touched on this previously, solution steps. So as I mentioned, we have solution steps now for solving ordinary differential equations, and that's what you saw earlier. But we also have solution steps for long division, solve, and matrix. The matrix invert command now has an option to return detail steps. So let me show you this. So here you go. Here's the solve steps for solving an equation or system of equation. And here I have the steps, the detailed steps for finding the inverse of the matrix. I now wanted to touch upon the Maple Learn content tools a little bit. So for those of you who are not familiar, who haven't heard, In January, we launched a new product called Maple Learn, and it's an online version of Maple which really focuses on teaching and learning math from high school to the first and second year university. And if that's something of interest to you, we have different webinars and recordings. But one of the things that you can do in Maple is you can actually, we have tools in Maple to support kind of authoring documents that can be deployed either in Maple or in Maple Learn. And so this is something that I wanted to bring up over here. So basically, it allows you to programmatically create these interactive applications. So in this example over here, we'll define an application that allows a user input and provides feedback. And so here it's with regards to finding prime. So it'll tell you whether a number is prime or not. So here's my function. And now I'm going to use the document tools canvas command. And this is what it looks like in Maple. So this is what kind of, I have a button, which is something that users have often requested. So now I can type in a prime number, click this, and I can enter in a new value. Let's say 5. And you can keep going, and I can click on check your page, and it'll look at each one and let you know if it's prime or not. So all of this, the document tools, Canvas, command, as well as all of the commands in this package can be used to create interactive Maple applications. But if you want, you can always use the command share canvas, and it actually creates a link that can now be deployed in Maple Learn. I'm going to click on this. And here is that same application in Maple Learn. So I can use type things on my canvas. And I can click on check page. So that's how it works. Let me show you another example. So we have a new solve practice command generates a command with that you can use. So let me show you. Here you can go ahead and solve this equation. And so as you do this, you can get a new math entry box similar to above. And here I can also go ahead and take this and deploy it to Maple Learn. And now I have the ability to solve this problem in Maple Learn. And I think a few of you who have going to make a mistake have been to some of the Maple Learn sessions. I've kind of touched upon scripting, and we will have more webinars to talk about it in some more detail. But just to show you how scripting and some of the things that you can do over here. I'm going to solve this. I'm going to click check my page. It'll go through this, and it'll tell me where I made a mistake, and I can go and then make corrections. So I can say, try that again. And so that's how you do it. You can also create practice sheets. So this is something that's been in Maple before, but here we have one. So you can have a practice sheet now generated directly here. You can also click this button and get a new sheet. Oh, there seems to be a mistake in my algorithm. I'll take a look afterwards. And you can also share this canvas. Similarly, for creating animated step-by-step solutions. And it kind of goes through step-by-step and shows you how it's being done. Just a few things that you can do with the scripting capabilities in Maple. And at this point, I wanted to talk about some of the improvements we've made to the interface. So one of the things that I think is a major improvement is now when you have kind of combination of text and math together in previous versions, sometimes you notice that the math would evaluate when you didn't want to. So in Maple, math can be, as you know, executable or non-executable. And before, we've actually added the ability to specify, I don't want the math to be non-executable with this toggle button here. So F5 now, before, you used to just go from text to executable math. Now with F5, you can go, it's a three-way toggle button. So you can go text, non-executable math, and executable math. This ensures as you're writing documentation and you want math formatted in a certain way, but you don't want that math to execute, it's very easy now to ensure that your math is non-executable. So this is just something you'll notice over here. This is all something that I can do. Another one is code edit regions. So pressing Shift plus Enter now inserts a new line, and pressing Enter executes the contents of the code edit region. So just, again, something to keep in mind to make programming a little bit easier. We also have a new option is available if you want to keep autosave files. So the Keep Files option is found in the General tab of the Options dialog. And if autosave is selected and this option is not selected, a backup is saved only until you recover your saved worksheet. And if this option is selected, the backup remains even after you use it in File Restore Backup. So this has been something that was requested, and we've added it into Maple 2021.